Okay, so IP version, chapter 12 is about IP version 6 addressing. All right, so there are issues with IP version 4. As you guys know that, well, one of the biggest issue with IP version 4 that the public addresses are depleting. Well, there's a solution, network address translation, but network address translation create latency and it's slower. Okay, so for that reason, and plus compared to IP version 6, IP version 4 is slow. Okay, so that's why there's need for different version of addressing on the network, and there comes IP version 4. So it's the same society organizations that are responsible for IP version 6 as IP version 4's ARI, and in depending on different regions. So, well, we covered that in previous chapter. Okay, IP version 4 and IP version 6 can coexist. Okay, so you have different method. One of them, the method is called dual stack. And in dual stack method, the devices can run both IP version 4 and 6 simultaneously. Then there's a method called tunneling, okay, where IP version 4, version 6 packets are transported over an IP version 4 network, okay, and these packets are encapsulated inside IP version 4 packet. And then there's translation, which translate IP version 4 to IP version 6. Okay. Now, so there's a reason there are different method of combining both IP version 4 and IP version 6, because IP version 6 has been used for past 30 years. Every device application uses IP version 4, and it's been around for so many years. So it's not just devices that uses IP addresses. It's the IP addresses are embedded in applications as well. So in order to just completely migrate from IP version 4 to IP version 6, it can cost a lot of money. Okay, so for that reason, there are techniques where you can combine both IP version 6 and IP version 4. And like, for example, older router, they cannot use IP version 6. Okay, meaning IP version 6 is not programmed into the operating system. So what you have to do is you have to either upgrade those all those routers, or you have to just replace with the newer router, and that could cost a lot of money. So it's just one example. There are firewalls. Okay, firewalls are very expensive piece of hardware and software. So if the company, so there are companies using IP version 4, and they're using IP version 4 firewall. So if they have to migrate from IP version 4 to IP version 6, they have to replace their firewalls. So that can cost also a lot of money. So when you go out there working, you will you would see most of the networks are IP version 4, but there are still some, especially ISPs and big organization are using IP version 6 in conjunction with IP version 4. So one of the biggest thing about IP version 6 is, like, the big difference is you guys are used to see 32-bit IP addresses, right? But that is converted into decimal. IP version 6 is 128 bits and is converted into hexadecimal, right? And it's it's presented in 4 hexadecimal values, each hexstat. So here they're divided into 1, 2, 3, 4, 8 hex stacked. Okay, if you remember, IP version 4 one field of IP version 4 is called octet, and in IP version 6 is called hextet. Okay, so uh, so there are four hexadecimal in each hextet. Okay, and this is how it's written. It's quite long. So writing IP version 4, you have to be very, very careful when you're typing IP version 4 addresses, okay? Because it's very easy to make mistakes. But you can trim IP version 4 address. So there are ways to reduce the notation of IP version 4 address. So there are some rules. One of the rule is to omit leading zeros, okay, meaning the first zero, the first zero only. Leading zero is important, not the trailing zeros, but the leading zero. So 01AB can be represented as 1AB. 09F0 can be represented as NF0. Okay, and so you can, so this way you can minimize the length of IP version 4 address. Okay, so but remember, yeah, only the leading zero, not the trailing zeros. So here this address actually can be reduced to this by 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 removing leading zeros. So that's one of so it's easier to type it in IP version 6 address. Rule 2, to further minimize the length of IP address, a double colon can replace any single or contiguous string of one or more 16-bit hex tags consisting of all zeros. So if there are all zeros, you can replace with double colon. Okay, so here you see this address has 000, which you already reduced. Okay, leading zeros are already omitted in this, and then you could further remove these zeros by replacing with double colon. Okay, so here the same address that we see before can even be further compressed by removing all zeros and replacing with double colon. So you can see here, so this address can be compressed as this 200, so it's much smaller or shorter. Okay, so it's easier for software to read, and also it's easier to type it in. Okay, now, so IP version 6 128-bit address converted into hexadecimal. Let's see what are the type of IP addresses. So just like IP version 4, there's unicast, multicast, or anycast addresses. Anycast is kind of address that can be assigned to multiple devices. Okay. Unlike IP version 4, IP version 6 does not have a broadcast address, but it has an address that can be multicasted, and it kind of give you the same result. So that's one of the advantages of IP version 6, because there is less broadcast. So you guys already know unicast, multicast addresses. So it's the same concept in IP version 6. Okay, prefix length, meaning the network ID. Okay, so so just like IP version 4, IP version 6 are also consist of network portion and the host portion. Most common prefix is, or the network ID is used 64 bits. So in a typical IP version 4 network address, the first 64 bits are part of the network ID, and the other 64 bits are part of the host ID. Okay, so if you see this IP address, okay, so the 64 bits are part of the network ID and 64 bits are part of the host ID. So if you have, like in IP version 4 address, if the class C address has 192.168.1.0, so 192.168 and 1 is the network ID. So in IP version 6, the first 64 bits are part of the network ID. Okay. All right. So there are, again, so there are you have two types of IP version 6 addresses. One is global unicast address, and second one is link local address. This global unicast address is like IP version public IP version 4 addresses. So if you recall, in IP version 4 you have public addresses and you have private addresses. Public addresses, the difference between those two, private addresses are not routable on the internet. They're only used in private network. Same thing in IP version 4, GUA, global unicast address, is the public address that is routable on the internet. Okay. And then you have link local address, or LLA, is only used in the local network. Okay, so it is so this is used to communicate to other devices on the on the local network, LLA. And it, just like IP version 4 private IP address, it is not routable on the internet. So remember that. So these are the terms you need to know: GUA and LLA. GUA is a public address and LLA is a private address. So the unique local addresses are have some similarity to the private addresses. So they're used for local addressing only within a site or between limited number of sites. Okay, they can be used for devices that will never need to access another network. So if you don't have a if the device doesn't need, so if you have, let's say, a subnet, if you're creating an IP version 6 subnet, and one of the subnet have devices, they are not supposed to go outside of their network, maybe for security reasons, right? So these unique local addresses can be used on that subnet. Okay, and these unique and these local addresses are not routed or translated to the global IP version 6 address. So why do you need to use these local address? Because sometimes you need to hide your network from the outside access. Okay, for whatever reason, maybe it's a research and development project, mostly where the outside public should not be allowed to gain access to that network. So you can use these local addresses in that type of situation. So just like IP version 4 public addresses, IP version 6 GUA, or global unicast addresses, are unique, okay, globally, and they're being used to access the internet. Okay, They currently only GUIs with the first three bits of 001 or 200 are being assigned. So the same Internet Society, the same organization that assign IP version 4 addresses also assign IP version 6 addresses. Okay. And there are billions of IP version 6 addresses are available. So these currently, so there are only with a decimal of 2 or 3 addresses are being assigned. So these 3. So how? So just like IP version 4, you have network ID, which is the global routing prefix, right? So for example, a class B IP address starts from 172.16.00. So 172 and .16 is the network ID, and the rest you can just assign yourself. So the global prefix on the is the portion of the address that are assigned to ISPs. Okay. And they're the so that should be unique, global prefix. Then you have subnet, just like IP version 4. You can further subnet your IP version 6 address by assigning different subnet IDs. And unlike IP version 4, you don't have to borrow bits from the host portion and create multiple subnet. Okay. You can create your own subnet in IP version 6 because you have so many bits to play with. And then, so you have global prefix, which is the network ID. The second portion of IP version 6 is the subnet ID, okay? And the third portion of the IP version 6 is actually the host portion that identifies a specific host. So it's equivalent of to the host portion of IP version 4 address. Okay. So as it explained before, LLA, a local link address, is used to communicate with other devices. Okay, on the network. These source or these LLA cannot be routed on cannot be routed. Okay, every IPv version 6 enable interface must have an LLA, local link address. So whenever you enable IP version 6, a local local address, a link local address is generated automatically. So even if you go to your Windows computer and you type ipconfig all, you will see a link local address assigned to your interface, which is generated by Windows operating system. If a link local address is not configured manually on an interface, the device will automatically create one. Well, that's what I just said. All IP version 6 LLAs are in the FE8000 range. So what is so in Windows, the automatically generated IP version 4 addresses in Windows starts from 169, right? So because this is a private address that cannot be routed on the onto a different network. So if your address starts from 169, that means that host cannot access other networks in IP version 4. In IP version 6, the same thing. When your address starts from FE80 only and you don't have the global address, that device cannot leave its own network and go to the other network. So it's the same concept. if you guys, those of you who understand uh, uh, the private address of IP version 4. All right, how do you configure those addresses? On a router, you already know, okay? So you go to the interface mode, and the command is, so IP version 4, you just type IP address, right? But if you're assigning IP version 6, you have to type in IPv6 address and type in the address, followed by the prefix 64. Okay, no shutdown and exit, just like IP version 4. Okay, on a computer, this is how you assign IP version 6 address. This is, you see, subnet prefix length 64-bit. That's the typical. Then you assign the default gateway, and then you can also assign, if it's a fully 100% IP version 6 network, you can also assign the DNS server address as well. Okay. You can also assign link local address manually. Okay. And you can assign a link local address manually so it can be easier to remember. Here, this is the command to assign link local address manually. So IP version 6 address, you choose FE80 colon colon 1, which is a link local address. It starts from, followed by the link dash local command. So this is how you do it on a router to configure the link local address. Now, dynamic addressing. So you have, just like IP version 4, you have a DHCP server that can be used to assign address automatically. So same way in IP version 6, devices can obtain IP version 6 address automatically. Okay, so the first step is router messages are sent by the host to discover IP version 6 routers, just like IP version 4. When you choose in your IP configuration to obtain IP address automatically, what your computer does is it sends a broadcast to the network looking for a DHCP server, which is called solicitation. And the DHCP server respond with the IP address. Okay, any available DHCP server respond with the IP version 6, IP version 4 address. So the same way in IP version 6, host devices sent a message to discover IP version 6 routers. Okay, then the routers send a message to host so they can obtain IP version 6 address. And what they contain. So when they assign an IP address, there is a default network portion of the IP address. The host receives the network portion of the IP address, default gateway, and the DNS address and domain name. Okay, so yes, so the concept is exactly the same as IP version 4. There's nothing new in IP version 6 except the type of IP address you receive are different. They're 128-bit hexadecimal addresses. So how do you assign? Yeah. So how do you assign IP version 4, version 6 addresses? Either you configure it manually, okay, without the service of DHCP server, or you can configure a DHCP server to assign IP addresses to the host. In this module, we will not discuss how to configure IP version 6 DHCP server. Okay, this is beyond the scope of this course. If you want to learn, maybe you can learn later on your own. And one of the reason is IP version 4 DHCP server are right now are not very commonly used, because there are not many 100% IP version 6 addresses. IP version 6 are available, but there is you can configure DHCP server to assign IP version 6 addresses. Okay. So they can be router can be send the IP version 6 assign IP version 6 addresses. Also, the routers can also assign a link local address. Okay. Okay, the link local address here. Each interface must have a link local address. Okay. LLAs can be configured dynamically. Okay. So here you see LLA is dynamically created using the FE800 prefix, which is the network ID. And it can take either a randomly generated number. So it can take randomly generated number, and in some cases it takes it copies the address from your MAC address. But mostly it just takes the randomly generated number as an interface ID. Okay, this here, the network ID is FE80 colon colon, but the host portion is randomly generated number for LLAs, and they're assigned dynamically. Okay, but you can also assign it manually. So if you go to your Windows and you type ipconfig, you will see a link local address that starts from FE80 FC99, and then it automatically assigned an address that is random. Okay. Okay, so whenever you assign a global address on a Cisco router, global IP version 6 address on a Cisco router, it also automatically generates a link local address on that router. So here you have, when you type, if you type show interface command, if you use the show interface command, you can see IP link local address here. You see this? This is the local link local address starting from FE80. Okay. How to verify IP version 4, IP version 6 configuration of your interface by using the show command. Show IP version 6 interface brief will give you the statistic of IP version 4, version 6 addresses that are configured on your router. Anyway, by the way, we're going to do this lab. Okay. That's what I said. Don't worry about the command. Command you can practice, and mostly in the lab they give you the command, right? Understand the concept. So the main thing you need to know about IP version 6 is that it's 128-bit, and there are two types of IP version 6 address: global address, which is like a public address compared to IP version 4, and a private address, LLA, link local address, which is like a private address in IP version 4. Then you have multicast addresses, just IP version 4, that starts from F008. So there are two types of multicast addresses in IP version 4. There is a well-known multicast address, and there is a solicited multicast address. One of the thing about multicast addresses that they can only be the destination addresses. Multicast addresses can only be the destination addresses and not the source addresses. So you guys probably know what multicast addresses are. They're sent to the group of computer. So you have well-known multicast addresses that are assigned and they're reserved for predefined devices group of devices. So there are two common multicast group. Okay, ff02 colon colon 1. Okay, this group enable devices that all IP version 6 devices to join. Okay, and then you have the F002 colon colon 2 that are all router multicast group. This is for routers to join the group. So these two addresses. Okay. Now, subnet and IP version 6, as I said before, is much easier. So here is the IP version for address that is subnetted. As you remember, so the 64 bits are used for the network ID and 64 bits are the host ID. So if you are subnetting, okay, so the 48 bits would be global routing prefix, and the 16 bits would be the subnet ID. Okay, so it's still this whole 64 bits is belong to the network, but here you also have 16 bits are used to subnet the network. And here, if you see, it's much easier. So if you have an address, you can just change these 16 bit to create multiple subnet. So you can start, so the first one is 0, right? So you can, the second one could be 1, 2, 3, 4, 5, 6, 7, 8, and so on. So this is how you create multiple subnets on in IPv6 network. You don't have to borrow any bits from the host portion, and you don't have to come up with the network ID and the host ID in each network. You can just use these 16 bits or this octet as the subnet ID. So now, just like IPv4 version 4, you have multiple subnets, and then you assign the IP addresses to router interfaces, okay, to each host on the network, that is PC, printers, IP phones, if they're using IP version 6. And then you can also assign IP version 6 address to switches. Okay, so when we go to the school, maybe those of you who completed other labs, you can create a fully IP version 6 network in the lab by using routers and switches, because all the routers, I think all 1841 series routers that we have, they are capable of running IP version 6. So that could be one of the a good lab, advanced lab for some of the students, where you set up the whole IP version 6 address, no IP version 4 at all, and see how it works. It would be a good practice. Okay, that you can come up with your own IP version 6 addressing scheme, create multiple subnets, and assign those to the devices. So who will be up for the challenge tomorrow? Let's create this topology tomorrow in the lab. And here you assign the IP addresses, IP version 6 addresses to all the devices, okay, with interface command. And that is the end of